I'm a licensed professional engineer, as Chad said. We are licensed in 18 states. I wonder whether we need to be licensed in 18 states because it is a monumental task to keep up with all that stuff. And I just had an administrative assistant leave, and I've got it all on my desk right now. So I'm trying to figure out what I want to do with it. But I'll tell you a little bit later as to why we got licensed in that many states. I've been in the metal roofing industry since the 70s, and finally I got out of college and started building a metal building. And so that had a metal roof on it. So I've gone from there to, and I'll tell you how that career developed. Picture of me in there, that's in the corner of RDU Airport. Again, it was a 6-year project for us to watch over that entire stainless steel roof, 450,000 square foot of stainless steel roof. So anyway, we're specifying a lot of states. We've done 45, 50 million square feet of roof. I was a contractor for 30 years, and then the last 20 years, I've been we specify and we watch over the projects. Next, I want to find out who, and I can't tell the guys that are and the gals that are on the internet, but how many people in here are contractors? We have contractors in here? No contractors. Engineers, I guess everybody's an engineer. We're going to be an engineer, right? And owners of their businesses, got the owners of the business, okay? And manufacturers, I don't suppose we have any of those. I do these seminars for a lot of different groups. And architects. Are there any architects in here? That's always good. That's always good. So we don't have any fights start. So anyway, the agenda I'll jump through real quick. I'm going to talk about pre-college and the ASCE University. I hate to use that because I really don't. I think they spent way too much time and money to get the word "the" copyrighted or whatever it was. They should have done something else with it. Then I was in design, build, construction, and retrofit roofing. Like I said, as a contractor for a long time. And then I started Metal Roof Consultants, and that's where we are at this point. And I'll tell you a little bit about the future, what's going to happen over the next year or so. So anyway, I was born in Southern Ohio, on a farm, and raised pigs and went to 4-H, and I decided I could make some money raising pigs. So I started a business, and I grew pigs and bred pigs. And that's how I kind of knew I was going to be an entrepreneur, which I've been my entire career. I went to an engineering seminar at Ohio State, had no idea what engineering was, other than I always told them I wanted to build buildings. I wanted to build, not residential, but always for some reason wanted to build buildings. And I went up there in my jeans and looking real good, my Converse tennis shoes and my white t-shirt, and walked up to the desk, and they said, we have a seminar here, but it's in different groups. What type of engineering are you interested in? And I stood there with a dumb look on my face for a while. I said, I don't know, what do you have? She ripped off about 15 different divisions that you could have in engineering, ceramic engineering, electrical engineering, mechanical engineering, whatever. And I said, which one builds buildings? And she said, civil. And I said, I'll be that. So that's what I made the decision that I was going to be a civil engineer, not knowing that within civil engineering, there's just as many divisions as there were engineering itself. So this is a really broad field, which worked out well for me. So I graduated there in '73. Took my EIT. I was told that you can take these EITs, engineering training. I think that's what they call them now, but maybe it's something else. But anyway, I took the EIT. They told me on Wednesday that I could take my books in and take this EIT if I wanted to become a professional engineer. I had no idea that I wanted to become a professional engineer. I just wanted to get through college. And so I took these books in thinking, oh, this is good. I'll be able to do this. I got a 69. You need 70 to get your EIT. I get 69. Boy, that's a great way to graduate on that. So 3 years later, I went to night school, took a refresher on that, took it again, luckily passed it the second time. And then I took the PE test in '77. Now think, I'm in the PE test. I've got a calculator and all the books I want to bring. There's no computers, I have slide rule. There's calculators, slide rules, and no computers or anything like this. You drug them in there in suitcases and sat down, and they gave you 8 problems to work. That's what they used to. 8 problems to work. I had a concrete pole, a flag pole. I had to design and different things like this and do a life cost analysis. I had some economic stuff that I was pretty decent at. And I got through that one. And about 3 months later, I got this letter saying that I passed. So I got my PE the first time because I told my wife if I didn't pass it then, I was probably going to become a plumber or garbage collector or something like that because I didn't. But I knew I wanted to have that, and I'll tell you why in just a minute. So I got in design, build, construction before I was even a PE, and I worked for a PE. So I needed that to get my 4 years of experience. And I learned everything that I was supposed to learn in college the next 4 years. Okay, so I didn't know what a footer was. I didn't know what rebar were. I knew how to draw them. I knew how to figure out what the clearances they had on the side and things like this. And then the field, I went out in the field and you look down in there, they're getting ready to pour the footer, and they got concrete. They got about half full of concrete. And I said, wait a minute, you don't have a rebar in there. They said, this is the way we put the rebar in. And they just dropped it and it sunk down into the concrete. And I thought, what about the 1.65 inches of clearance I needed on this side and that side and whatever? So finally got to use tools. And but you had to adapt. You had to adapt very much of what you learned in college and what you're going to use in the field. So I learned that. I had to do everything. Prepare drawings by hand. CAD had not even, nobody knew what CAD was. They thought it was CAD spelled wrong. Okay, there was nothing at all in CAD. No computers on the desks. And so we drew them. We had desks. We had electric erasers. Some of you will remember those electric erasers with the brushes that would, because you always tore them, and then you mess up one sheet and you water it up and you start another one. It took forever to do the drawings, and then take them to the building department. And of course, the building department then would red mark all over them and stuff. And you go back and you draw them again. I spent more time drawing things than I did anything else at that time. But you learn every line, what every line meant on that drawing. So you learned that it really meant something. You put it on there. So anyway, I bought the material. I sold the stuff, the buildings. I bought the materials. I managed the men. That was the most interesting part, just to manage men that were 20 and 30 years older than me. But did that. I got a lot of experience. Got a lot of good ground experience. But then when I got my PE, then I realized that now I could do the design, and I didn't have to depend on Stan, who was the guy that was the engineer in the company. And so it made a big difference. And I saw people respected me a little bit more once I got the PE after my name. Not sure that, I deserved it at that time, but at least you get the respect so they would listen to you. So anyway, in '79, I'll tell you how this ties into it. I designed and built the first metal retrofit roof in the country. Now I did it because my son was born that year and we had no money and there's nobody buying construction. And so I had to do something. So a guy convinced me to try to do that on a 50 by 50 building roof that they had. I'm going to show you a picture of it in a minute, but I found out later that it's the first metal retrofit roof in the United States. Had I been smart enough and had the money to patent it at that time, I probably wouldn't be here now because I'd own an island someplace or whatever, because it's a very popular thing now, but we're still, that's our niche. We're the leader in the country in metal retrofit roofing. So anyway, it became obvious that the added value for the PE. When I designed that first retrofit roof, there's columns, there's fasteners into the existing. Of course, I had everything in hot rolled steel that was welded. Now it's all light gauge steel that's screwed together. So we've lightened it up some, but we did it, but it didn't work, and it's still up. And that's the one on the, sorry, hit the right button here. This is the building right here. We built that building, design build for the customer. They manufactured their product there. They tried to store it in here, but it leaked too bad. It was a flat roof, it was a concrete flat roof, and it leaked horribly. And they said, why can't we have that roof on this roof? And I told him, you can't, because it's never been done before. And the guy looked at me and said, that's a horrible excuse. You know that. There's some way it can be done. So we figured it out. And then the one next to it is a job that was, our first big job that we did is about 110,000 square foot manufacturing plant. And we figured it out, how to do wider buildings, how to do higher framing, how to put the insulation in there to vent the space. And a lot of different things had to be, and there was no book. There was nobody that had done it this time. So we had to figure it all out ourselves, keep notes, keep our calculations and stuff. And we're still doing it relatively the same way. This was I think I'm look a little older now. This was an article that was done on me and our company about how we were doing this. And I think it's in 1983. So this is 10 years after I've been out of school. And the fire station talked about what was going on. So we were getting some publicity and people were getting to know who we were a little bit at that time. 10 years after that, I was asked to do the workshop at Oak Ridge Laboratory about, because now the question was, you're going to add pitch to a flat roof, you've got a cavity in there, what do you have to do? Do you have to take out the old roof? Do you have to dry it up? What do you need to do? And there was a kind of a competition as to which way it needed to go. When we had that roof that I just showed you, that big roof, I went back and checked it every place. and it was completely dry, 100% dry. The wet insulation, the decking was not rusted. Everything up there was pristine because we vented it 3 to 5 times an hour. 3 to 5 times an hour, we found out was the right way. Today, it's 3 to 5 times an hour because we know it because it's been tested, and we know that that'll keep the space dry. So we can figure out the cavity and figure out what we're going to do with it. But that was published then, and then 10 years after that, I was asked to write an article for the Roofing Contractor magazine and talked about 20 years of being in metal retrofit business. I just recently wrote one last September for a seminar I did in October about 50 years now. So I added 30 years to this one. So now we've got 50 years that we've been in this and doing this type of stuff, and it still works. I'll tell you why in just a minute. Now I'm going to give you, and this is a YouTube video that we prepared, and it talks about retrofit roofing. So I'm not selling anything here, but I want you to understand the concept of that, because that's what I use my engineering for, to be able to develop this, and it's provided a career for me and my family for 50 years. So I want to explain that to you. If I can set it up, if I can do it. There we go. Can you hear that all right? All right, I'm sorry, those of you online. Sorry, those of you online that you couldn't hear that. If you want to hear that, just let me know. Send me an email or whatever, and I'll send you this whole presentation. You'll be able to hear it. So, but that kind of explains to those of you that were here. Hopefully, you heard most of it. The system that we developed back in the late 70s and have carried forward to today, actually. And what we're doing now, that some of the loads change, ASCE 7 changes wind loads, and we have to keep up with those, and 16, and now I'm getting ready to start using 18, and what codes and the different states that we work in is what we have to use. But the engineering on it is still the same. It's still metal to metal connections, bracing, expansion, contraction, heat and thermal movements, and wind loads and dead loads. We have solar arrays we're putting on there now. We have to start thinking about that also. So it's it's very adaptable. It's very easy to understand. So anyway, and it's been very successful for us and also the districts that we do work in. We do a lot of school work, and once we do one, we do basically the whole district. We're just finishing Davidson County, the 35th building we've done in the last 34 years for them, and all of them now are metal. They have a zero operational budget for roof repairs at this point. So that's what usually happens as soon as the people know exactly what could happen. There we go. So I'll go through this quickly, and these are the clips that we talked about. Find the existing structure. We have to load that structure in a way that is compatible with the way that was originally designed. We can't put point loads in the middle of spans and things like this. So we have to go through and do an analysis of that structure. The existing building code that came out a few years ago allows us now to only add, if we're only adding 3 pounds a square foot, we don't need to analyze that structure. We still need to load it properly. We don't need to analyze the structure itself. And almost all the time, the weight of this is less than 3 pounds a square foot. So we fit right into that category. We don't tear off the existing roof. Again, the code says if in fact you're going to load the structure and not the deck, then you don't have to take the existing roof off. So we have the existing roof on there, and they still can, the schools go on 12 months a year, we work 12 months a year, and there's no loss in school or anything. So So anyway, that's then the post we talked about, variable height post. We got clipped and variable height post creates the pitch. Here's one that's probably 3 and 12 or 4 and 12. We can go down to as low as half and 12 for the panels, for the warranties on the panels. So we just create a little metal building on top of a flat roof building, what we're doing. This shows the finish once you put the roofing on there. We've got a lot of units and everything. And this is an aerial of that picture. When we took the video, I was right there. No, in this particular job, it's for Brunswick County. As you know, down on the coast, all the hurricanes, everything blow through there. This is 110,000 square foot middle school. You can see that the units. Good to see the units that we have on there. We have some very large units, recovery units, energy recovery units. We had to put penthouses around and they get the water to go around that. We had courtyards to work with. We had to figure out how to get the water on the outside. All that type of stuff. There's a lot of things going into it because we're changing the dynamics of that roof. They like this one. We did another one exactly the same size and another one exactly the same size than all their high schools. So we've got about 800,000 square feet of roof in Brunswick County. And when the last one came through, and they had a lot of leaks, a couple of the flat roofs that they still had. There wasn't one thing on these. We've never done anything on this since 1988, 89, first time we put one on. There's not been a thing, no gutters, no downspouts, no leaks, zero leaks. So people trying to get in there. So anyway, that's what it ends up looking like, and of course it makes the school look nice too. So we can do metal over metal. Sometimes there's metal roofs that leak, existing metal roofs that leak. This was one in Alabama, Mobile, Alabama. And because of a PE, again, I kick everything back to PE. All this has to be designed. Structural, metal roofs are structural, and they have to be by codes, by general statute, they have to be designed by a professional engineer. So that's what we do. That's what I do. And so anyway, this one's in Mobile, Alabama. I went out there and analyzed it and found out that they had their clip spacings all over the map, and it didn't handle the wind load whatsoever. They're right on the bay there and didn't handle the wind loads at all. $2 million later in the lawsuit, they had us tell them that they couldn't do it, and then also tell them how to put this one on, and we got it all covered over. So it's the same color. They don't know the difference. So this is what it looked like at the end. This is what it looked like before that, but structurally it wasn't right. And something's done structurally wrong, you can tear the whole building down, or you can figure out how to retrofit something over top of it. And that's what we did in this particular case. All right, in the 90s, I had a roofing company. We were the largest one in the United States for like 15 years, from the mid 80s to early 90s or early 2000s in putting them on. So we had to design them. We designed them, and I managed. We had the men. We had 125 people in the field and 3 offices, and we were doing a lot of work in a lot of different places. And we learned a lot about metal roofing, on how to put it together, and we became very good at engineering it and also having constructability. We've had specs and drawings that come out that are constructible by the contractors. I heard people talking about the contractors. We have very few of them anymore that are available, but we need to know how all this stuff goes together. So we had to follow the building codes. And I also then, during this time, I started doing a lot of seminars and writing articles and things like this, because people would ask me to speak about it. So here I'm talking about PE. I'm not talking about the roofing, but I'm talking about the PE was the cornerstone of that, to be able to do that. And if you can be in whatever discipline that anybody may be in, use that, get the PE, number one, for the students this year, get your PE. Don't forget to do that, because that goes a long, long, long way. And get your PE, because it opens up doors and continues to, I'll just bring this up one thing. What's the most credible profession in the United States, has been for the last 25 or 30 years? Most credible profession. Anybody? Nurses. Guess what's 2? Engineers. Always has been for the last 20 or 30 years. They believe what we say. Everybody had taken an oath, and they believe what we say. We have to protect the public, and we do protect the public. And there's some failures that happen every once in a while, but there's not very many. Doctors are 5th or 6th, and lawyers, they're in the 200, I think, or something like that. And car salesmen are 250. That's as high as they go. So anyway, but it's a very reputable profession, and we all we're very proud to be engineers and know that that demands respect. And also from a financial standpoint, it demands more money. The more desired you are, the more you can do, and more things that you can give back to the owner, the more they're going to pay for it. So we also do a lot of legal work where we're expert witnessing and legal work, and that pays even more than actual engineering work. But the PE got us there. That's where we get all the leads. All the leads come through because we're a PE company. So metal roof consultants, we started it in the early 2000s, and the first project we did was a lawsuit. Then we got into the RDU airport. Let's see what time is. Okay, I won't go through a lot of this. I'll show you the pictures rather than go through a lot of what this says here. The airport, May 7th, 2004, I wrote a proposal to them, and it was for, I don't remember how many dollars it was because I thought it was just a small project. I didn't know it was a project. They brought me in a room and they had a cardboard model of RDU Terminal 2 laid out. And I said, where's the drawings? I said, we're starting the drawings based on the model. They built the model first. That's before we had any of that modeling that we have now in computers. And they looked at me and they said, and we want to put a metal roof on there. I had to analyze, see what kind of metal roof. Stainless steel was the one we decided on. And we want you to be around and watch over the whole roof as we're putting it on. 6 years later, well, we got finished with it. It was a very mania. Instead of, I don't remember what it was, $4,000 or $5,000 I was quoting them to there just to do the initial analysis. It was considerably more than that over the time. So it was a very good job for us. It's a picture of me up doing some of the inspections. This is the one portion of it. You'll see another portion. The major part of the roof, the center section that goes out over the cars where you're dropping people off. That center section is 456 feet from one side of the building to the other side. And they said, and we want one panel, no laps. We want one panel. We had to roll the panels in the field. 22 gauge stainless steel. We tore up 3 different forming machines by the time we got done because it's so hard to bend stainless. And we had to handle that from 456 feet. Now the panels are hard enough. They had like 35 people pulling this panel across it. It had 7 radiuses in it. So we had a radius machine they had to run on before they put it up there. And then they had to put it down. And then we had to figure out where to put the fasteners. You know, the clips we talked about in the video, we have to have something to hold that down to the deck. And so we had to design those fasteners. Now we could design how close to put them together. Problem is, this thing's going to move. It's going to move 456 feet. We've tried to fix it in the middle, and that didn't work because it just popped the seams off of it. Once it started trying to move it to the edges, we had 5.5 inches of expansion contraction. We had to design for them both at the edges. So we had to have special clips because most clips only do an inch. So we had special clips and we had to know where to place them. I had to be out there with a thermometer at the times we were putting these clips in to tell them exactly where to put the clip. Now, again, they're paying PE numbers for me to be out there telling them where to put this clip. But that was, it had to be done because it was such a structural element. We had a tough time with that one. But anyway, I won't go into too much more detail on that one. But we got that done. This is, it's not that exact same section. This is one of the sections right next to it. And you can see all the expansion and contraction we have up to all these steps. If you ever go out there again, now look at it. All these steps for expansion and contraction, these are stable, the walls are stable, the panels are moving 2 to 3, 4 inches around those. We had to have sliding joints on all those. And this shows the one on the side here, shows the clip. That's the biggest clip that would remove a total of 5 inches. So anyway, that was, and then the complicated ones are where they're going like this, where they come together and they have a crisscross. Now you got metal moving this way, and you got metal moving that way, and it meets right here. So we had to come up with ways, and that's before we had a lot of modeling software or anything to work with. So we tried to draw as best we could, but the bottom line is I'm out there on my belly trying to tell, okay, no, you fix it here. We got to make sure that it can move, or it'll just pull itself apart. And we had, I think, 25 or 26 of those on the entire project. So the engineering of it was, look at it now, it looks nice. It's a stainless steel roof, it looks nice. But the engineering to get it put in place right was not easy. It was difficult, but we got through it. This just shows, this is a retrofit roof, kind of showing another picture. I thought I'd throw that in because it shows a little bit better than the video did. There's where we put the insulation on the existing roof. And here's the the variable height posts, moving the units up and whatever. This happens to be a large project we did out in Johnson County, Clayton Middle School, or Elementary Middle School. And this is one of the Davidson County jobs that we just recently finished. So on the right is a picture of when we were putting the clips in. This is what it was. It was a flat roof, leaked, couldn't fix it. The last roof they had on was 12 or 13 years before that, and it was a mess. And so we went in and we sloped everything different directions to get it away from the inside of the building to the outside of the building. The gymnasium, an auditorium, full school. This is the Ledford Middle School, and we've done the high schools, all these different schools we've done there, and it solves a problem. But again, it's an engineering. The reason we could do it was because we were engineers, an engineering company, and we know how to put these components together. And this was, I think, the last one I'll show you. This is one in Buncombe County. We've done a dozen jobs or so in Buncombe County. We did this in 5 stages. They funded it 5 different times in 5 different fiscal periods. And we did it, and it was about 165,000 square feet, cost a total of $3.5 million, I think, by the time we got it all done. And just finished it up a year and a half ago, I guess, or something like that. But again, they have no more. This was all flat concrete roof that they had on here before. Now it's sloped. It looks good. It's all blue. This is the color that they wanted, and so it's very sustainable. By the way, the metal on it is 100% recyclable. Now you're not going to recycle it until 80 to 100 years. Even that, I mean, the stainless steel is going to last 250 years. So the galvanized steel, I won't go into the details on that, but we know that it'll last 80 to 100 years. So you're putting a membrane down here that will last anywhere from 80 to 100 years, as opposed to a 15 to 20 year membrane down there, or shingles, sometimes less than that. So we feel like we're not only doing a good job and helping our customer, but we're also doing something good for the environment. We're always adding insulation to it. Moving the air through there has a value for keeping the inside controlled, and of course more insulation all the time. This is the Smithfield High School that was another one we did in Johnson County. In this particular case, we've created a whole new entrance for them, and some of this framing is up 17, 18 feet now. I mean, we get really high with the framing, and we just have to brace it differently. It's just watch. I always call it the arrows. Watch the arrows, what the loads you're going to do, and make sure those arrows get down into the existing steel. So anyway, that's what we had there at that job. In the future, that's pretty good. In the future, we're going to continue. MRC is going to continue. Now, it's an engineering company, so I'm going to stay on as the engineer. Now, the engineer in the company that we do now is we're writing specifications, watching over the jobs, things like this, which we have field people that can do that. I have to make sure that I read their reports and whatever, and I have to do the engineering to start with, but I've already done the engineering. We just have to apply that engineering to these projects. So I'm going to be able to stay on. My son's taking over the company, so he wants his mother and I to not move in with him. So we're going to make sure that we have enough coming out of it to be able to survive that. But I think, as I put in here, I think it's time to start retiring after 50 years. So my wife's finally convinced that I'm not going to totally retire, or I drive her crazy. So I like to play golf, but I'm not that good. So I don't want to do that 5 days a week or 6 days a week. So I'm going to have something to do, and with the lawsuit stuff, that's always going to go on. So I'll be handling that stuff. So I'm going to keep my fingers in it, but it's going to be maybe 10 hours a week instead of 70 or 80 hours a week. So that's retirement as far as I'm concerned. So son's taking over, 43 years old. He's got all new, he's turning everything around, new logos. He's going to, take the thing and run with it now. And I'm turning it over to him. It's hard to be quiet because I've been the leader. I've been the main person for a long time, but his mother's coaching me as well as she can to keep quiet. So anyway, that is how having a PE guided a 50-year career. So what was your name again? Luke. Okay, Luke, you're a junior. You got one more year, then you're 50 years.